Okay. Okay. Come to our next part of the vector quantities will be our unit vector. Okay. So what is unit vector for? From the word unit, it actually tells us that the unit vector have a magnitude of only 1. Whatever unit you want to have. For example, 1 meter per second, 1 meter per second, or just simply 1 meter, for example, for displacement. Where do we use unit vector? Alright. So when you write down answer or a vector quantities, you have to mention the magnitude and also have to tell direction. But most of the direction when we refer to in physics or mathematics are with reference to the Cartesian coordinate system, which is your x, y, z. Okay, so that 3. And they are already fixed. They are all orthogonal. That means they are 90 degrees from each other. X is 90 degrees from y, y is also 90 degrees from z, and so on. So they are more or less something like this. Okay, so unit vector is a convenient way to represent a vector in that Cartesian space. Alright, so this is our Cartesian coordinate system. This is our x, this is our y. So we are using right hand coordinate system here. X move to y, your thumb point up, that's the direction of your z. But I cannot draw like this because you cannot see the sense of dimension, so I draw this way. Okay, so that is our 3-dimensional space. Okay, 3-dimensional space. So a unit vector can be represented by a 1 unit of magnitude in all these direction. Okay, so you have a 1 unit vector, 1 unit vector here, and also 1 unit vector here. Our unit vector has a symbol that is already fixed. For example, x, y, z, we use a symbol here, I, j, and k. Okay, so they all have this vector sign here. But to tell people that it is a unit vector, we put a small cap at the top. Pakai topi. Okay, a small cap at the top here. So that represents unit vector in respective direction for the x, y, and z. So how do we use it, for example? Okay, so we can actually write down a vector like a displacement vector. Okay, a displacement vector is given like 2i, okay, and then plus 3j, and then plus 2k in the unit of meter, let's say. Now what does that value mean? That means the displacement is 2 units in the x direction, and then followed by 3 units in the y direction, and followed by 2 units in the k direction or in the z direction. So because the I, J, K represent the x, y, z. Now you might ask one of the question, why don't we use simply 2x plus 3y plus 2z? Isn't it so much more easier? But I have to remember one thing. If we use 2x plus 3y plus 3k, there might be a possibility that it clashes with the algebra symbol x, y, z. For example, you are doing something like simultaneous equation. You have y plus x is equal to some number, and then have another 2y minus 3x is equal to some number. Now that x and y are simply x and y value for the coordinate. It's not a unit vector. So if you use that x, y, z to represent our unit vector, there will be a confusion between the usage for both of them. Alright, so that's why we stick with the I, J, K. So that means in our case here, our S is something like this. You're going to move 2 units in the x direction, 1, 2, somewhere here already. So I'm going to use the green color. Now you're moving 2 units. Okay, there's a 2i, and then followed by 3j. 1j is this long, so 3j is roughly here. Okay, so now this is your 3j, this is the 2i, and then plus another 2k. K is out, okay, out, 2k. 1k is this much, 2k is here. So in reality, it is actually pointing out like that, 2k. One here, another vector here, so somewhere around here. So your vector now is starting from here and up here. So you have a 3-dimensional space, something like this. Okay, it's quite difficult to imagine, but don't worry, because in your case, you only need to learn 2-dimensional. Okay, 2-dimensional, that means only on the surface of the whiteboard. You don't have something like this. Okay, that one you learn in a higher order of physics and mathematics. Alright. So in this case, our 2k, if we follow this direction, is going to be here. 1, 2. So somewhere around here, there is our 2k. Alright? But you have to know in reality the 2k is coming out. So that means your vector will be here. This is going to be your vector. Initial point, final point. So your vector is somewhere around here. So this is your vector S. Okay? It's difficult to imagine that because this is a 3-dimensional vectors. Alright? So the purpose of unit vector is, okay, we write out the purpose. Okay, the purpose of unit vector to represent a vector more conveniently in our Cartesian coordinate system. Okay, is to be more conveniently represent vector quantities in Cartesian coordinate system. Okay, so that's why we have this unit vector type of things. But this is not just 3 of the unit vector. There are actually a lot of symbol used for some other coordinate system. The coordinate system that we have in physics and mathematics, we have Cartesian coordinate system, we have spherical coordinate system, we have cylindrical coordinate system. All those systems can be transformed from one to the next. But this is a basic one. You're learning starting from this, and then when you go to a more 3-dimensional scenario, you might need to use coordinate system that is like spherical, like robotic arm, spherical, and so on, and then cylindrical, also robotic, rotational things. Okay, those are much more complicated system. Okay, but they also have their own unit vector. All right. So at the moment we just use IJK, but in your case you're going to use only most of the time I and J only for 2-dimensional. Okay, so there is a unit vector. Other example of unit vector, it can be something like velocity, unit vector velocity. It can be like negative 5i plus 7j and then minus 1k in meter per second. Right? So these are just example of unit vector that we can use it. So that means by looking at that, you are telling people that the velocity is like this, minus 5 meter per second in a negative direction on 5, and then 7 meter per second in a positive y direction, and then negative 1 meter per second in the opposite z direction. Okay, the negative z direction. So that IJK is a very useful and is a very powerful way in representing vector, and because of that, we're going to use this method in solving some of the vector summation. Okay, vector summation. But before that, we need to know how to change a normal vector in space so that it can have 2 components I and j. That is our next video on resolution of vector. How do we split vector into 2 components? Okay, keep updated.